Good afternoon. Welcome to the show. I'm Jim Flyzik. During today's show, we will discuss how the government is taking advantage of that big explosion of big data and using it in government programs. And with me today on the show are Zack Goldstein, the Chief Information Officer and Director for High Performance Computing at NOAA, Duncan McCarthy, the Technical Executive for Innovation at NGA, Jim St. Pierre, the Deputy Director, Information Technology Lab at NIST, Diana Zavala, the Director, Analytics and Data Management, U.S. Public Sector, HP Enterprise Services, Chris Borneman, the Vice President, Software AG Government Solutions, and Alan Ford, Director of Presales Consulting, Teradata Government Systems at Teradata Corporation. We're going to talk big data. Boy, it's a hot topic. And I guess when I think big data, Zack Goldstein, we'll start with you. I think NOAA, lots of data at NOAA. Give us some examples of where you are in making some progress with some of your big data initiatives.
So for those of the listeners who aren't familiar, big data generally is what NOAA is about.
Right.
Everything from generating a weather forecast to assessing the health of a fishery. It's all about data. All of our products are data products.
Right.
Some of the places where the data is the largest and where we're making the most recent progress in big data are probably in our satellites and in our high-performance computing. Mm-hmm. So the next generation of satellite GOES-R on schedule for going up in the next year. GOES-R will increase the amount of data coming from geostationary orbiting environmental satellites by 7 times.
Oh, wow.
And we're going to be needing to move around that data. We're going to be needing to process that data. And so we're putting in place the networks to do so. One of the networks we have is called NWave. It is currently a 10 gigabyte speed network nationwide. We have now plans to upgrade it to 40 gigabytes. It moves around our research supercomputing data, our operational supercomputing data, and our satellite data. So we have that happening. And then in the high-performance computing side, thanks to the Congress's reaction to Hurricane Sandy, where they chose to increase our computing capacity so that we could increase, and they also funded explicit research in hurricane forecast improvement. Okay. We've been able to make substantial improvements in the capacity for high-performance computing. So one of the increases is that next September we'll be upgrading. We've just awarded the contracts recently, and by next September, our operational supercomputing will be at 5 petaflops. Wow. Nationwide. A recent increase we made to our operational supercomputer back in the winter allowed us to, this is a little bit geeky, but allowed us to get our global forecast system resolution down to, or up to, down to 13 kilometers. Oh, wow. So each forecast point covers only a 13 kilometer square area. And that was a big deal in the meteorological community. It resulted in the most accurate snow forecast ever. We got the Boston forecast within under an inch. Oh, wow. The snow event that occurred recently. Most important, I'm going to get jingoistic here, for Team America, we beat the Europeans. Which is important. And on the R&D side, we're currently at 2.7 petaflops. We just accepted our most recent supercomputer. Her name is Thea. Okay. I looked at her yesterday in West Virginia. Okay. She looks really nice. Okay. And she was a three times increase over her predecessor Zeus. And last, and I'm going to be quiet. Last. And I'll talk about it more later, I think, we're making really good progress on the big data partnership. Okay, good. Which is open data applied to big data. Wow. Probably going to have a new name for big data. It sounds like big data is getting to be bigger and bigger data. I mean, what names? We're going to have to coming up with new names for this stuff, as we move along. Duncan McCarthy of NGA, give us some examples of areas where you see NGA making progress with big data.
Well, it's interesting you just mentioned that thing about big data. We've struggled with the same issues with what actually defines big data, whether it's many pieces of information or large pieces of information. For years, the NGA has actually been dealing with what we would consider large data, which were enormous data files, in the gigabyte range, images of that size. It's very different when you're engineering a system to deal with large data, in terms of throwing images around at that scale and size, as opposed to dealing with many little small bits of information. However, I think in general, NGA is working with the Director of National Intelligence to try to make use of the environment that was given to us by them, and going to try to cope with the new way of doing business. That traditionally we have been an agency which takes data in the form of imagery and hands it to people to try to work with, and they would look at it. Well, there's two fundamental changes that are coming, in the world that we need to cope with. The first of that is that the internet is here. It looks like it's going to stay, and so now we have millions or perhaps even billions of images and other geospatially tagged bits of information that transit the internet every day, and we need to be able to make use of some of that information. It's public, it's open source. Sure. In addition to that, there's you mentioned the satellite going up. There's multiple satellites coming up in private industry. So many that it's going to dwarf the amount of satellite information that we've had in the past. That in the past there's been a small number of nationally owned satellites. Now, in the commercial industry, there's a plan for more than 200 Earth imaging satellites that are coming up within the next decade. Wow. What that means is you can no longer do the same, you can't operate with the same paradigm anymore where you take the imagery down, quickly disseminate it to a bunch of people who look at it. Right. When you get a 200-fold increase in the amount of imagery and a 1,000-fold increase in the amount of data that's transiting the internet, unless you have 200,000 times as many people to be able to analyze that, you're fundamentally broken.
You're going to need sophisticated business analytical tools.
Exactly.
It's it used to be find the needle in the haystack. Now it's find the needle in the stack of needles.
Exactly. So we're making use of supercomputing capabilities, things that are developed on Wall Street and stuff to try to...
I was involved with the reinventing government. I don't take credit for inventing the internet, but I do take credit for inventing modern-day wireless. I was a Bluetooth guy out there well before people thought Bluetooth was sort of like a Dr. Seuss book or something. Diana Zavala at HP Enterprise Service. How are you structured? And give us some examples of how you're supporting your customer base in this area.
Yeah. So big data is really impacting everyone. And for instance, we're working with a global nonprofit organization called Akshara, and their mission is really to drive the best learning experience for children in India, over 800,000 children in India. In that particular region. And we're helping them to collect and analyze information really at the locality level, the school level, and even down to the classroom level, so that we understand characteristics about those children, but also understand characteristics about the environment itself and what impacts that learning environment and situation for children. And there's a population of those children, particularly between the ages of 11 and 15, that are high risk for leaving the educational system. So we're coming up with what are the key factors to help change that outcome for those particular students. And that includes everything from the distribution of learning materials down to the fact that having separate washroom facilities for boys and girls, especially for children during those ages, actually have an impact on the outcomes of them staying in school.
Wow, that's a tremendous story. That's great. That's great. What a great use of technology and data. Jim St. Pierre, I know NIST plays roles in setting up frameworks and standards and guidance and so forth. Tell us what give some examples of things you're doing with big data.
Sure, thanks, Jim. Thanks for inviting me to be part of this panel today. So I'm glad to tell you about some of NIST's efforts related to standards and measurements from big data. We're working, it's part of our efforts to support U.S. innovation and competitiveness. That's part of the NIST mission. We recently released a 7-volume, I think was one you were referring to, that maybe brought me to your attention, was the NIST Big Data Interoperability Framework for public comment. So that's out now. I'll say more about that and how people can do that. So what are these documents about? So despite the widespread agreement that big data is going to have huge impact and many benefits, there's still some fundamental questions that can be confusing to people that want to use big data and integrate big data. Like, what are the attributes that define big data solutions? How do big data environments differ from traditional data environments? So this NIST Big Data Public Working Group, a public-private partnership, was created in 2013 to address these and other questions. The group is charged with developing consensus-based definitions, taxonomies, reference architecture that includes security and privacy, and a standards roadmap for big data that can be embraced in a secure and privacy-protecting way for all sectors.
Great.
The interoperability framework was developed with extensive partnership by industry. The draft, this is the draft, it's out for comment. So we really welcome feedback by industry, academia, and government, other agencies from across the U.S. And the goal of the framework is to provide a vendor-neutral technology and infrastructure independent framework to enable big data stakeholders to identify and use the best tools, so you can plug in your best tools and visualization tools on the most suitable computing platform to allow you to get the most value and get the most out of your big data. So one way to think about the framework might be as a sort of somewhat analogous to a blueprint for a house, right? We're very good at building homes and buildings when we use a blueprint. So the framework is sort of a different kind of blueprint. It lays out and informs you that you need walls and the
Sure,
components, right?
sure.
Algorithms and analytics. But it doesn't tell you exactly how to put them together. But we don't have that same ability to do that in big data solutions right now. So it would be very helpful if people could plug and play things together, tools to get at the knowledge that's locked in that data right now that they want to get at. So the working group has, in the 7 documents, address things, like I said, taxonomies and definitions to just help people have a common language.
Right.
Use cases to what are some actual ways you're going to use this, security and privacy, and the reference architecture itself, and a standards roadmap to where are we going in the standards to support this. So we're seeking public comment on those 7 documents. The comment period started April 6th, ends May 21st. And you can access those documents by going to bigdatawg.nist.gov. There's plenty of time to do this. So I
encourage our listening audience to take a look
Great.
and get some feedback into you. That's
you.
great stuff. You know, you're exactly right, because other big data shows, we talk about, the concept of big data, and people talk about, tools and business analytical tools to manipulate big data and everybody's doing something different with big data. But nobody, in my opinion, prior to this, has talked about sort of a management framework of how do you handle, how do you have like a disciplined approach to managing big data in your organization. I think that's, and obviously the NIST document could probably go a long way to addressing some of that. Chris Borneman over at Software AG, how are you positioning, and how's the company positioning to support this big data movement?
Okay, great. Yeah, there's actually 3 areas that we've been focusing on for big data, and part of it actually builds off of what Jim was getting at in terms of how you access data. And one of the first areas we've been focusing on is from an open data perspective. How do you control the access to data? So if we've got data locked up and we're trying to go through and share it, how can you enable it? And we believe through web services, make it as accessible as possible. So how can you go through and ensure you have the right security around it? And secondly, understand the life cycle of all those interfaces, all those APIs over multiple years for those programs. And then most importantly, I think, is tracking the access. Who's actually accessing the data? Not so much of the individual, but which programs are accessing it, so that you understand how it's being used. Is it worthwhile data? And can it be correlated to other pieces of information? The other area that we focused on was bringing big data online. So if you look at lots of data that's on disk, opening it up to the outside world is slow, right? And you have limited resources inside your organization. And can you go through it and start accessing information and providing it out to third parties that traditionally have been using your resources? So we focused on how to take the information and put it online in memory. So it's very, very fast. It is not taking up your internal resources associated to it. And most importantly is that now that it's been made accessible, you actually can start using it real time to make decisions, rather than just doing a report and say, here's what happened last year, here's what type of inappropriate payments we made last year. How can I start going through and detecting that stuff right now while someone's filling out the claims? Right? And so we believe you need to make that stuff online. And then lastly is that if you're doing this former 2, the last piece is correlating real-time data. So if I have all this data and making it available inside of my system, how do I then monitor new data that's coming in and compare it to what I already know? And can I start correlating that to other data sources as well? And what kind of patterns can I start detecting against that? And what kind of decisions can I make now where I can still affect the outcome? Right? And so we see great applicability within fraud, within abuse, cybersecurity, But even in like preventative maintenance, can you go start predicting when maintenance should occur inside of all of our aircraft and vehicles within our various government installations?
Yeah, terrific. And I know the listening audience has heard me say this many, many times, but I see us moving to a world where decision making is, or we're making decisions in a world where time's approaching zero. I mean, decisions have to be made in real time immediately in a lot of situations. Alan Ford over Teradata, how are you positioning to support this big data movement in your customer base?
So we at Teradata have been working to build out a unified data architecture that includes big data as part of this architecture, and open up this formerly rarefied area of analytics and big data to a wider business analyst community. So building in the ability within our database platforms to reach into the non-traditional areas where big data is stored, like Hadoop and things like that.
Right.
And so no longer do your analytical resources have to be experts in MapReduce programming, but you can open up the world of SQL business analysts, let them start exploiting big data. So that's what we've been focusing on at Teradata.
Right. Yeah, I know there's been a lot of effort too, you know, and not just structured data, unstructured data, all kinds of media, ways to pull together from all varieties of sources. It's coming a long, long way. Duncan McCarthy at NGA, give me an example of a specific program at NGA that you're working that you think big data will really make a difference.
I guess one of the specific ones we have is Geowave. What we noticed was that whenever you're trying to deal with geospatial information, you'd use a regular database like Postgres or Oracle. Those databases weren't inherently able to do geospatial type of computation, and so what they did was they modified them with add-ons, Oracle Spatial and PostGIS, to allow them to do geospatial computation. One of the things we've done is we noticed that Accumulo was a large database out there for handling geospatial or for handling information, but not geospatial information. So we wrote this program called Geowave, which now enables Accumulo to work with geospatial information. We also put that online on GitHub, and so now everyone worldwide can bonus off the U.S. government's contribution here to the open source piece of software, Geowave, and so you can now do many different types of geospatial computation using Accumulo, which is based on HDFS, and now gives everyone the ability to do geospatial computation.
Very cool, very cool. Jim St. Pierre, as you work this framework, do you have a specific program in mind that that could be, the framework would apply to?
Well, there's a lot of play. Let me tell you how that's a good question, the way we phase the development of the framework. So we're hoping that from the framework there'll be an architecture that, as I said, is vendor neutral, technology independent, and that it really allows people to think about their data problem without having to worry about the underlying infrastructure, right? That's where you'd ideally like to get. So the way we're approaching that, the first phase, the first set of documents that are out of phase one is defining the components of that framework, of that architecture, right? What are the pieces you put together and to do data analytics on big data? The next phase after that will be updating those documents and then talking about the interfaces between them, right?
Okay.
So you're building a system with components and you have to connect them together. Right. So how do you think about those interfaces? And then, so that's where we'll use use cases. We're collecting use cases of various ways, to, whether it's healthcare or, various energy or whatever it is, transportation. And then validate those components and how they're put together in the interfaces using some of those use cases. So that's the phases we'll go through, and that's how we'll
Terrific. Exciting stuff coming down the road here. And I want to hear from the rest of our panelists on the same question, but first we need to take a short break. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM. Welcome back to the Federal Executive Forum on Federal News Radio, 1500 AM. I'm Jim Flyzik here with Zack Goldstein from NOAA, Duncan McCarthy from NGA, Jim St. Pierre from NIST, Diana Zavala from HP Enterprise Services, Chris Borneman from Software AG Government Solutions, and Alan Ford from Teradata Corp. We're talking big data. When we went to break, we had heard from a couple of our government panelists, but we haven't heard from Zack about a specific program. Zack, can you identify a specific program? Our listening audience also likes to hear, give me a program that this actually is going to address. So if I asked you that question, where would you go?
I'd go right to the Big Data Partnership.
Okay.
So the Big Data Partnership is is NOAA and the Department of Commerce's move to change the way that big data can be turned into open data.
Okay.
So open data is something we're working on, of course, across government. We all are improving our websites, making them more accessible, fixing metadata, and so on. Right now, recent statistics that came out show that the two top websites in the federal government are weather.gov and NOAA.gov, with the exception of the recent tax season when it becomes IRS.gov.
Right.
But normally, it's those two. So we already have a lot of people using our data and downloading our data. When industry comes after our data, as they do because there's a billion-dollar industry, multi-billion-dollar industry based on our data, there are no AccuWeather satellites, and the Weather Channel uses NOAA radar.
Right.
Those are NOAA satellites, NOAA radars. All the observational systems are taxpayer funded. But so is the high-performance computing infrastructure and those websites, and in the future, we, as in the past, we've discovered that we can be victims of our own success. So we build industry, industries grow, there's better uses for our data to do better transportation forecasts, agriculture, fishing. It's almost unlimited. And we've got to come up with an alternate way to be able to get the data out there, grow the American economy, and not bring our infrastructure to its knees or bankrupt our budget. So the Big Data Partnership protects our infrastructure from the demands, as well as promoting industry by stimulating the creation of alliances with anchor partners that will work with NOAA to get our data. Only 10–20% of our data is actually already made available publicly. Get the rest of the data out, put it in cloud services, provide value-added services for those anchor partners and their alliances, grow industry in the process, and hold our resources and infrastructure harmless by including in their cost function the costs of the government to get the data to them.
Huh. Interesting. Very interesting.
And that's what it's about. We're really excited about.
Yeah, good. Yeah, I know you mentioned the IRS. I'm told the busiest day in downloading for the IRS is April 15th, the downloading of the extension of time to file form. Alan Ford, can you give us a specific program where you think big data is going to make a difference?
Certainly. Let's talk about the condition-based maintenance of military vehicles.
Okay.
We're going to start seeing sensor technology everywhere within military vehicles, and if you're able to, in real time, track the performance of a vehicle out on the battlefield, know that because sensors are reporting something is wrong, that this vehicle could be degraded, and if you can have another one ready to go behind it to replace it, if you can be prepared for any sort of maintenance situation by tracking the performance of your vehicles and knowing what part is about ready to fail, through predictive algorithms, you'll be much more efficient, much more cost-effective military.
Wow. You know, somebody once told me that in the future, the value of the electronics and the intelligence inside cars will be more valuable than the car itself. We'll see. Chris Borneman, how about the specific program that you would throw out there as one where you think big data will make a big difference?
Yeah, actually we have two real-world examples that I talk about today. The first is healthcare.gov, because that's, I think, something that is very visible. I'm sure everyone will recall back in 2013 during its initial launch, it had some scaling issues. Yeah. It made the news headlines on a daily basis.
I think we may have heard that.
it may have made the news. But if you think about that, the system had to go through and pull information from many different systems across multiple agencies, and then in real time assist the user in their selection of which plans they're eligible for based on the information that's being collected. And it really was an issue of big data and multiple data sets that needed to go through and be processed. And what we're able to do is to bring in our Teradata product and start caching the information in memory. And everything was preloaded. And you'll see that back in our kind of a newscast, all of a sudden, that problem went away. It was no longer a performance issue because we were able to bring that data, take all that big data, and make it available in RAM so it was accessible across multiple users. And if you think about the initiative, it also forces a lot of people accessing the same data in a high-performance situations, hundreds of thousands of people coming in to go through and see what they're eligible for. So the system scaled up very well. And compare and contrast that to this last open enrollment in 2014 went through very smoothly. Now, there's plenty of other enhancements that were made through a lot of various people, but big data caching is really a big important part of that. And related to that then is the FBI Index program, which is a program that multiple agencies, state and federal, are all contributing. Okay, perfect. I'm sure you would by your background. Are contributing into that. And all that is going into a big data in-memory situation so that all your investigators can go through and do their searches in real time. So it's a system that's got hundreds of millions of records. It's got over 2 billion information entities that are associated to it, hundreds of gigabytes of data coming in on a daily basis that's constantly updating this data. And it continues to go through and scale and process everything in real time. So we've got plenty of examples, I think, in the real world already using existing technology.
Yeah, excellent example there. Diana Zavala, how about HP Enterprise? We heard a little bit about things you're doing overseas. Are there other specific programs you'd point to that you think are real good examples of where big data is making a difference?
Yeah, so I'd like to bring up another example where we're working with the Norfolk County Council as well to really help families at risk. And we're doing that by partnering with them to bring together disparate sources of data, information that's really locked into not only databases on the structured side, but forms and documents on the unstructured side, and mining that information around, particularly around families. And how can we help families that could potentially be at risk? And we're doing that by really uncovering with our HP technology unknown connections and patterns that aren't obvious to people or caseworkers that are looking at that information in silos in particular. And we're helping to then provide timely social services to those families that might, truly be in need, whether it's an unemployment event in the family, some domestic issues, et cetera, and really helping to safeguard families overall.
That's terrific. I mean, really appreciate you bringing out these kinds of, human kinds of ways that big data can be applied, and, to address social issues and to help people, essentially. Appreciate you bringing some of that stuff to light, because I think we have a tendency to think big data and technology, but we don't sometimes relate it right back to the human side of things and the difference it's making. Let's talk a little bit about some of the lessons learned as you've gone through this process. Let's start with Duncan this time. Duncan, what are some of the lessons you're learning as you're migrating into this world of management of big data?
I guess one of the most important lessons is we need to have a good architecture. No matter there's many different ways to process over an exabyte of data, and there's direct attached storage, there's Amazon type scalability where you're spinning up machines and spinning them down, and having an architecture where you keep your keep the data in a place where algorithms can be pushed to the data rather than moving the data around. It seems to be critical. So that's our big lesson. Other lessons are that we need to try to staff up and hire the right people. They're very hard to find. They tend to be very expensive. It's just difficult to get. We can write a contract and put out an RFP for these folks, and it's hard for industry to even find them because they're in such high demand.
Right.
And the last thing, I guess, is is culturally. Need to try to prepare the culture for an entire new way of doing business. Especially for us, which has a very long legacy of here's the image, look at it. Now we need to bring in people and train them and change the idea of how you build intelligence products. No longer are you just looking at the image saying, well, there's 5 tanks here. Now you should be able to get that fully in an automated way and be able to operate at a higher level, essentially putting pieces of information together, try to tell the story.
Right, excellent. And Tom Trezza, I think we need to get an award for the person that brings up the word culture. This is 119 shows now. Culture has been in every single show. Someone brings up along the way because we're talking about change, and people bring up the fact that there is a culture associated with change. Zack, what do you think? Zack Goldstein, what's some of the lessons you're learning along the way here?
So it's about culture. No,
No argument there.
I'm not sure if that's the biggest lesson. Actually, a lot of the big lesson learned is about culture. I'd like to focus on the big data partnership and lessons learned we've had thus far. We are going through a cultural change whereby it's not about buy a server, put a web server on top of it, and serve the data up.
Right.
This is about get out of the way. Right? We're into saying, well, I know what the public wants to hear. I know what products they need. No, this is about getting out of the way. So in the big data partnership, the biggest lesson learned is that we need to back off from the idea that we're going to be specifying what the American economy needs. We didn't develop the weather industry. We just developed forecasts and products. Industry knows how to do this. The American economy works just fine.
Right.
So what we're learning is that the key is that we're not going to be developing the technical solutions. We're not going to be developing the products. Our partners and their alliances will be figuring that out. Right. They'll be figuring out both of that, and we'll be working with them to come up with the best technical means to make our data suitable for the value-added services and the serving up that they're going to do.
Yeah, excellent.
And the other big lesson learned is that policy is going to be playing a big role. Fortunately, we've been in this for a long time. Our focus has always been, of course, on protecting life and property, protecting the economy, regulating fishing, and so on. But this idea of open data, where other people are using our data for different things, there are branding issues, there are quality issues, there are equal access to data issues, and anybody who might go into this kind of an arrangement needs to go in with an open mind, not be open mind, but be mindful that policy is going to be playing a big role, and if somebody does that, we've got some experience we can help.
Sure, absolutely. Jim St. Pierre, what's some lessons you're learning as you put this framework together?
Yeah, Jim, we've got a lot of history at NIST and working with industry. It's really our former NIST director used to refer to us as the industry's lab. And so we've worked in areas prior to this that have some lessons learned that are affecting our big data work, such as cloud computing and smart grid. In both those areas, we found definitions, just allowing the diverse experts that were involved in those complex systems to talk to each other is really important. And a reference architecture that lays out what are the pieces that make up these systems gives you the context to, again, talk about what are the offerings you have and how does it fit into what I need and what are my needs and to quantify my requirements. So we've learned from that, and we're applying those same kind of things here. And a reference architecture shouldn't be prescriptive, but rather should be flexible and allow to support innovation and competitiveness. And working with industry, as I said, is a strength of ours, and we really enjoy that. That keeps our work exciting. I think one of the things Duncan said, and Zack, that really about getting out of the way, or, we think of that also as, industry leading, like working with them. And they really have, in smart grid, for example, they had the infrastructure is all industry owned, but we still, found ways to help them. And this idea that Duncan touched on about the algorithms moving through the network or through this framework, I think that's really important because, it's somewhat analogous. You don't ask the piano player to tune up to you, right? That would be a heavy lift, right? So
example.
You try to move your algorithms to the data just so that you can be more effective. So that's just one of the creative lessons learned.
Terrific. Chris Borneman, what do you think are some of the lessons you're learning as you work your way through the big data world?
Yeah, sure. We've seen kind of a pattern across our customers, and the first area is really starting small. This thing is more representative of the project that you're trying to accomplish with your big data. And leverage that, learn through it. It'll provide some value and help you build credibility with your agency. It also can help grow your funds. Along those lines, also choose a partner that can come in and help you prove it first and prove it fast, so that before you go and make those big investments, you know what you're getting into. You know you have a high probability of success to go through and do that. The second piece that we've seen on big data is look at beyond your initial data set. So if you can start combining data from different sources, you start gaining a lot more intelligence than just what you knew already.
Right. Yeah.
And then lastly, once you've gone through and identified these patterns, look for ways to go through and automate. Start detecting that in real time. It's a lot easier to go through and prevent a mistake before, rather than going back and analyzing where the mistakes were and then trying, hopefully, to recover against that.
Yeah, get proactive, get out in front
And be
of it.
proactive against it,
Yeah.
exactly.
Diana, Zavala, what do you think? Some lessons learned along the way here?
Yeah, I think similar to what Chris said, when you're starting out in the world of analytics, you really want to Start down the path with data discovery in particular. Use a test and learn approach where you're developing use cases. You have the potential to derive that return on investment for your organization. And you want to choose use cases that will obviously have an immediate impact overall. And then do a quick proof of concept. We say, test often but fail fast so that you can essentially move on. But do that in a short proof of concept. Once you get your questions answered, you want to then operationalize that. Because if you don't do that, you're not going to sustain the ROI that you're looking for.
Sure.
Whether that's reducing fraud, optimizing your supply chain that we talked about, or serving your citizens better.
Yeah, excellent. Both you and Chris talked about that. Start small, prove yourself, don't jump. I guess we're seeing that right across the board in technology, the agile development, everything. When you do the big bang theory and try to do the big multi-billion-dollar thing all at once, we've seen so many failures that it's now, let's build them piece by piece and put it together. Alan Ford, what do you think? What are some of the lessons learned along the way?
Well, I think 5 years ago, big data was a scary thing. The initiatives were complicated to implement, but the open source community and private industry has really come along with a lot of very good tools to help implement big data initiatives. So it's no longer so scary. It's no longer in the experimental realm now. It's coming mainstream, and being able to productionize now big data initiatives a lot easier now than it was just a few short years ago.
Yeah, you're right. I mean, you go back to my time, when IRS first went electronic online, and we were just throwing servers at it. Need more servers. I think we've come a long way, and have gotten a lot smarter and strategic in how we're going to manage all this stuff. We're going to talk about some challenges, and then we're going to talk about the future. But first, let's take a short break. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM. Welcome back to the Federal Executive Forum on Federal News Radio, 1500 AM. I'm Jim Flyzik here with Zack Goldstein from NOAA, Duncan McCarthy from NGA, Jim St. Pierre from NIST, Diana Zavala from HP Enterprise Services, Chris Borneman from Software AG Government Solutions, and Alan Ford from Teradata. We're talking big data. We've been talking about progress, programs, lessons learned. Let's talk about the hard stuff. What are some of the challenges, the things that are hard that you're trying to work through, the things that you got to accomplish to get where you want to go? Let's start with Jim St. Pierre. What's some of the challenges you hit out at NIST, Jim?
So in general, working in the information technology space is challenging because of the rapid change, right?
Sure,
Things
absolutely.
More than just about any other field I can think of, IT is moving extremely quickly,
And
right?
it's complex.
And it's complex. So that presents challenges, especially in the data area, big data area, and in the standards area, right? So some of the things we do there to try to approach that is to focus, as I said earlier, on interfaces and to allow that connectivity. And wherever possible to enable backwards compatibility and technology neutral approaches. But it's challenging to take that technology neutral approach, but it's really important so that users can configure the best possible solution without having to be locked in, that our industry partners are always advancing and pushing hard on the state of the art, and people want to be able to use the latest thing and be able to plug that into their environment.
Absolutely.
So that's one of the big challenges we see, is just trying to enable that.
Yeah, excellent example. Zack Goldstein, what do you think? What's some of the challenges or the hurdles you got to get over in order to get to where you want to be in this program?
So mention culture again. Culture isn't actually the biggest challenge.
Okay.
We've got a very good history of making products that protect lives, tell people what to do, when to do it, and getting out of the way. We actually do that pretty well too. The big challenge internally in terms of our use of big data is telecommunications. We have a very complex path going from a satellite, a buoy, a radar, a river gauge, a tide gauge, all the way through supercomputers, models, dissemination systems, display systems, a lot of value added from the humans,
Sure.
and then warnings, watches, and all sorts of other outputs. And as the volume of data increases to drive through that primary mission essential function value chain, as we call it, we have to make sure that we have adequate pipes at every stage, and we have redundant paths, and it has to be resilient. And building that and keeping up with the major investments that we're making in terms of billions on new sensors, making sure that we don't end up getting a bottleneck anywhere along the way is actually a big investment planning challenge.
Absolutely.
And getting the money for it. On the external use of big data, well, the big challenge is being the victim of your success and growing the American industry, which is why we're going with the Big Data Partnership and our hope to address that challenge.
Right. Excellent. Well said. Duncan, McCarthy, what do you think is some of the challenges you face day to day, the hurdles you need to get over, those constraints that need to be dealt with in order to meet the goals you're trying to achieve?
I suppose some of the big challenges that we've had, two of them, one of them was working with open source. As you know, I work for an intelligence community agency, and so when you say you're going to make something public or go to the media, they immediately start thinking about how much jail time you'll do.
Yeah, right. I did 18 years of Secret Service, and I know that very well.
And so when I said we wanted to build these modules, the Geowave, which can be downloaded, or Mr. Geo, another one that stands for MapReduce Geospatial, which can also be downloaded. They're both on GitHub. Those things, when I said we want to make these open source, there was a lot of reaction in the agency, like, what? However, by making these open source, then we can bonus off of the capabilities of people at other agencies, the capabilities of people worldwide, to be able to further develop those things. I think the other big challenge that we've overcome or working to overcome is in setting up this big architecture. We need to take into account kind of this new discipline called DevOps, or development operations.
Right. I hear about DevOps all the time.
Yeah. Building the environment which the developers can work in and quickly be able to stand up machines and deliver capabilities. That's been a bit of a challenge. I guess the last one, briefly, is contractual. I mean, anytime you work for a large government organization,
Absolutely.
when you come up with a new way of doing business, what you hear is, we understand Agile and we'd like to develop the thing that you're interested in. If you could come back to us in 18 months, that's the next time that we'll be able to take into account your requirements.
Right.
And
And you said earlier,
yeah.
get good people, it's expensive, get good contractors, it's expensive, yet contracting people push towards, low price, technically acceptable, so you got to go through all that justification of why we really need to get the best, and the best and brightest in here. Excellent point. And on that, the open source, I know some of the argument made to me was, if you go open source, you can see the bits, so you can secure the bits and you know what's there. When you're in some proprietary solutions, you're not necessarily sure what's inside.
And they end up costing much more in the long run.
Yeah, true. Absolutely, for maintenance and upkeep. We're getting down to the last segment of the show. We got about 13 minutes to roll here, and we always like to talk about the vision, sort of like we talked about the present day, your challenges, your lessons learned, progress you're making, but what do you see down the road with big data? What's big data going to mean to the world we live in down the road? What's it going to mean to programs we manage and so forth? Alan Ford, what's your crystal ball look like? Where's this all going down the road to you?
Well, Jim, sensor technology is going to be everywhere. According to the Gartner Group, there's going to be 26 billion devices on the Internet of Things by 2020. That's just 5 years from now.
Wow.
A few years ago, not too many people knew what a petabyte or an exabyte was, and we'll be talking in 5 years in the realm of yottabytes and zettabytes, things like that. You're going to have chips in farm animals. You're going to have sensor technology in automobiles, roadways, bridges, enabling smart transportation networks, making them easier to manage, helping to mitigate traffic problems, promoting safer and more efficient transportation. You'll have tracking technology in military theaters, enabling real-time tracking. We alluded to that earlier with being able to increase the state of readiness with our military organizations. You're going to have chips in field operation devices to help firefighters fight fires in a safer manner, mitigating risk. Even my toaster will want to be on the internet in 5 years. But it seems counterintuitive. But as the data gets bigger and the information generated from it gets better, the costs and resources required for managing systems and environments that these data come from should get smaller. And that's a good thing in these days of ever-increasing budgetary pressures.
Absolutely. The Internet of Things is coming quickly. Chris Borneman, Software AG, what's it look like to you down the road? Where's this all going?
Sure, a couple things. First, building off of what Alan alluded to, along with all those additional devices that need to go through and do things real time, really comes to the forefront. So I think we're going to continue to go through and see paradigm shifts as to how we've approached problems in the past. We'll need to think in the now. And that really is a big difference and a game changer for a lot of the ways we approach problems in the past. The other area, I think, is that if we're exposing our data with our open data initiatives and anonymizing certain information to make it more accessible, as there's an opportunity for crowdsourcing to go through and discover those patterns and kind of work together with our own constituents. An example I give is I learned recently, actually, it was University of Washington had an issue with folding proteins. And so a couple of different groups inside of the university got together from the biochemistry side as well as the game design groups, and they created a game called Fold It, and they put it out in the public domain to go through and actually fold proteins. And they had a problem in particular that they had been working on for 15 years and couldn't solve it. And by releasing it in this way, and crowdsourcing, no payment or anything, they were able to solve it in 2 weeks.
Wow.
So I think there's a lot of opportunity as you look inside our government data and make it exposed securely, anonymized. But what are the opportunities we can go through and crowdsource some information and overall become better at it?
Absolutely. A great example. None of us is as smart as all of us. So if we get all those minds thinking of the problems, they get solved a lot faster. Jim St. Pierre, what's it look like for you? Where's this going? Where are we going to be because of big data down the road?
So from the standards perspective, I'll say that the vision would be to help create a really standards-based interoperable environment that is technology, vendor, and infrastructure neutral, that is secure and privacy enhancing, right? That allow anyone, industry, government, students, researchers, to focus on their data and algorithms, analytics, and what they want to do, and help them really focus on getting the knowledge out of the data without having to worry about that underlying infrastructure, right? To make that as easier, and that's just plug and play. They can get to the data they want to get to. So that's the big challenge, is getting from where we are today, which is great. We're making some great strides, but even advancing more to get more of that knowledge out of the data. Another vision for the future is to be able to better measure. We do standards and measurement in this. Better measure the big data solutions and challenges. As you can measure things, you can understand them better, you can improve them, and we've had a number of examples of that we've done in different IT arenas that have helped industry, and they've been a great partnership where it helps advance the technology.
Sure, excellent. Well said. Diana, Zavala, what do you think? What's this look like down the road to you?
Yeah, so as a combination of the things that we talked about, really a realization of big data and the Internet of Things overall. That includes the use of social media to influence decisions on a more regular basis, capture data from our connected devices more readily, and use that data in more real time. Alan mentioned the proliferation of sensors that will be out in the world. That's all going to be coming together for effective use. And I actually see this as really culminating in the fruition of safe cities, kind of a connected communities construct where citizens and government are really going to have much more highly efficient and effective interactions overall. And a particular example comes to mind. We're actually helping communities and cities monitor through sensors and through video surveillance what's happening between interactions of people that are bicycling throughout cities, as well as what's happening with motorized vehicles and the interaction between those two. And in those cases, you're looking for ways to improve signage, roadway design, put in the right policies, and change the way communities interact with each other as well in order to affect citizens' lives.
Wow. Excellent examples again, just of how the technology is going to be able to, improve day-to-day living in around the world. Duncan McCarthy, what do you think? Where's this all going, Duncan, down the road? What's the future going to look like as a result of this big data trends?
Well, our director, Robert Cardillo, likes to talk about consequence. I think there's two huge consequences that are going to come about as a result of big data. One of them is a fundamental change in the way we do business internally. That is that my vision of the future and what we try to bring about in the laboratory that I run is that try to have analysts that can interact with large volumes of information very quickly and in an easier way, because more of it will be analyzed essentially in a fully automated fashion up front for them. So if you try to remember the movie Minority Report, where Tom Cruise was there and he was interacting with data with his hands and passing around images, it was an easy way of being able to work with data. It was much better than sitting in a workstation, downloading an image, getting it 30 minutes later, and then starting to look at it. So my internal consequence, I think, is that analysts will have a much easier time working with data. The external consequence is, I think, in speed for our agency. Our agency will be able to essentially answer questions much faster if we're monitoring things going on the internet, images from all over. Once an event like a plane begins to get lost over the Indian Ocean, we'll be able to detect an anomaly that much faster and be ahead of the news. Rather than watching CNN, we'll be saying, well, okay, here's what CNN will see in 10 minutes.
Yeah.
And I think that's the second
Yeah,
consequence.
excellent example, too. You know, the example of the plane, the ability to have the information, the sensors, the things in place to know when things like that are happening and where they're happening, and to respond, again, in that in a world where decision-making's approaching time is zero.
And in some cases, save lives because of that.
Absolutely, absolutely. I love it's come out in this today, that the human side of big data. Zack, Goldstein, what do you see, Zack? Where's this all going down the road? What's the future look like?
So building on saving lives and getting ahead of things, we're largely in the prediction business, and we expect our predictions to get better and broader. So predict the impact of air quality and the impact on human health is something we can get by using more complex forecast models that include lots of data about atmospheric chemistry. Understanding, predicting the impact of climate variability and climate change on the health of fisheries, and always saving lives. So more tornado warning time, more accurate hurricane forecasts. And something that's really important about forecasting is it's not enough to tell people far in advance what's going to happen. They have to believe it, because if they don't believe it, they won't act properly. If you get the forecast wrong, or if they think you've got it wrong, they won't believe you, and then people die.
Right. Yeah, that hurricane scare again. Sure, I don't really need to evacuate.
Right. Well, I survived the last one. What's the problem now? So one of the things that we get from big data and how we improve our modeling is that making better models will make a more accurate forecast and a more narrow range of who has to react to it. But by using ensembles of different models, we're able to better quantify the risk associated with it. So people know that, well, we're saying it's a 70% chance. It's not assured. If it's 90% chance, we've got high confidence. And if we can use big data and modeling of that to improve the way we characterize how certain we are, then we believe that the sociological impacts will be such that people will be better responding to the better forecasts that we can produce. That's all happening on the inside. But the other big thing in the future is when you combine big data with open data, now we're talking about growing the American economy in ways that we've never seen before. Transportation, agriculture, fishing, shipping, the Internet of Things combined with open data from the government, getting that big data out there and finding ways for people to leverage it, that's really exciting as well.
Cool. Very good. Some great stuff here. I love doing these radio shows because you guys all keep me smart. You know, for me, it's like I'm a sponge. I get to hear from everybody across government. Let me try to do some conclusions. I take notes as we go along here. We had some great examples. What impressed me right off the top is a 7 times increase in the satellite data we're going to be getting here in just a very short period of time, which means to me there's no stopping this big data explosion. I mean, there's no signs that it's going to do anything but continue to grow and grow and grow. We also heard, interoperability frameworks are going to be important because all this data has to somehow work together. Specific programs, we heard a little bit about Geowave, the big data partnerships, and moving big data into the world and marrying it up with open data. We talked about smart cars. We talked about Index in the law enforcement world. And we talked about big data addressing social issues and actually being used to help people. Lessons learned, you need a good architecture. Culture is always going to be an issue. It's not to do it, it's to get the data out and get out of the way and let the practitioners who understand what they want to do with the data, let them decide the solutions. Start small, prove it first, and then move forward. Challenges, speed of technology change is a challenge. Telecom infrastructure with the amount of information moving through all the various components that's there. The vision, sensors everywhere, Internet of Things, crowdsourcing could be used where we can get a lot more brain power addressing issues, better intelligence, better predictions, better models, and of course, the one that's important that came up over and over again, actually saving lives. I think that's, in the long run, that's the most exciting thing coming out of this. Let me do a few thanks here. First, thanks to our panelists for taking time for your busy schedule. I know you all have very important positions and taking some time to come share your ideas and your knowledge with us in the listening audience. Thanks to our sponsors, without which we don't have a show. We appreciate you being here. Thanks to all the great people here at Fed News Radio that do such a good time accommodating us each month. And most importantly, thanks to the listening audience out there that tune in and listen to the show. You've been listening to the Federal Executive Forum on Federal News Radio, 1500 AM.